All right. Let's see. Is it coming live? Are we getting on here? Excellent. All right, I'm gonna pull that over there. Alrighty. All right. Let's see. Can I pull this panel out? There we go. Perfect. All right, welcome into the live. My name is Andrew. Today I am going to be going over the first LeetCode problem called TwoSum. To explain it, this is like given an array of integers where that array is num. So like, for example, this right here, nums is equal to an array of numbers like 2, 7, 11, and 15. We are looking to find a target. We're looking to find two integers that sum to a target integer. And that target integer in the first example is 9. There we go. I'm like trying to figure out how to that shall work. Okay. All right. We have constraints. There's exactly one solution. We have exactly one solution. And our constraints are that the array will have at least 2 numbers and as many as 10,000 numbers. And why this matters is because if the array is too small, then there's not any solutions that work. Almost any solution works, okay. And if there are too many elements, then it'll be a slow solution. And that can become problematic. Especially if we're brute forcing. If we think about like traversing 10,000 elements to find two numbers that sum to our target integer, then it's going to take us like an exponential, like a very long time. Our second constraint is that so this means that each number in the array can be negative, 0, positive, very large size. Okay. So we basically this is how big the numbers can be. That's huge. But this means each number in the array. Okay. The second constraint means that this means that each number in the array nums can be, I think it's like that. Oh yeah, that worked. Can be negative negative, it can be a 0. It can be positive. And it can be very large in size. Okay. Why this matters, all of the numbers are positive. You cannot assume that all the numbers in the array are positive. Okay. And the array is sorted. You can't assume that the array is sorted. You can't assume that all the numbers are positive. And you cannot assume that you only have small numbers. So, like, here, that means that it could be nums equals -3, 4, 3, and 90. And your target could be 0. So there is a solution, -3 and 3. Okay. And target is 0. So, and the, oh wow. So the third constraint here is going to be that the target can be very large, very small, or 0, negative, or positive. So that means we could have targets that are -8. We could have a target that is equal to 0, or you can have a target that is equal to, in this case, up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, a trillion? Or that's a billion. Okay. Why this matters, you can't build a solution that only works for positive targets. Okay. Wonder if these notes, oh, I can make them positive. I'm actually going to do this. We're going to move over to here. Okay, so we're going to move this down. Example. Nums and target. Did I miss? I did. Okay. Let's bring this over here. And then bring this here. Perfect. Okay. I don't know why I did that. Heading. this is a markdown file. Okay. Dope. Alright. So let's go ahead and build out. I'm going to watch a video. We'll build out a solution. Cheers. So these would be nice. I plus 1. Oh. I want our I to go from 0 to the end. So we would like for I in range. And we want it to start at 0 and go to the length of nums. Okay. And then in our inner loop, we want for each I, we want for j in range from I plus 1. So, okay, into C. So I plus 1. And we want it to go the length of the nums array. Okay, that actually makes sense. And then we need to see, so when after our first loop is going to be going for I in range starting at 0, indices 0, going the length of the array, the nums array, and then we want to an inner loop that's for j in range of I plus 1, which is like basically starting at the indice 1, and we want to go the length of the nums array. And then we want to check if nums I plus nums j is equal to the target. And if they are, then we're going to return so this is the brute force solution. We're going to return I and j. So this solution is technically accepted, but there's a better one. Okay. Trying to decide. Need other number we'd need to if we have that number checks if we have that number available. Current number plus number needed equals the target or we need to check I actually don't like this guy's explanation. Sorry for this channel's explanation. Let's go here. I'm actually watching.
For number 2, a new question comes up, which is, can we structure the data so that we can quickly see if we have number needed? And if I think through all the data structures, I can see that a map can help us do that. If we store each number as a key, we'll know if we have number needed in O of 1 time. That would give us O of n time overall, and then we would need O of n space for the map. So we know we want to store each number as a
I want to give a call out to this guy. This is the first time that I've seen it visually explained.
key, but what do we store for the value? It could make sense to store indices since the question says we need to return indices anyway, and then we could use those indices to make sure that we don't use the same element twice. But a number can appear multiple times in the array, so do we store all the indices where that number occurs? That could be complicated, and the time and space complexities are not obvious. Now, storing just one index would be our other option.
Shout out to Gordon here.
But it's not obvious it would work. And if we did, which index would we store? Now, when building the map, the most obvious thing would be to do something like this. So we initialize the map, loop through the numbers, and then save each number as the key and the index as the value. And if we see the same number again, we'll overwrite the old index with the latest one.
Okay, so alright, so let's see. This was the brute force solution, and obviously it works. I'm just gonna comment. I'm gonna actually assuming that. Okay, good. I just like to have it there. There we go. All right, so we're number to indice. Okay, so we're creating a dictionary, mapping number to indice, number to index, and then enumerate. So for I, number and enumerate. See, I don't know. For I. Let's see, Python. For I, number, and enumerate. syntax. In Python, the syntax for num and enumerate list is used to loop through a collection while keeping track of both the index position and the value simultaneously. Okay, so let's see. Enumerate, a built-in function that takes an iterable like a list, string or tuple and returns pairs containing a count in the original item. So so it returns index and value. Okay, so it's gonna iterate through our array of integers.